The second geometry, the cylinder. So for cylinder, we will consider a cylinder with axis perpendicular to flow. So most often, a cylinder contains a fluid inside. The fluid that is inside the cylinder is either being heated or cooled by another fluid that is flowing perpendicular to its axis. So the equation for predicting the average heat transfer coefficient of the outside of the cylinder for gases and liquids is as shown previously, okay, or this one I put it here also, the Nusselt correlation, where we have the constant C and M here. C and M constant could be obtained from table 4.61. Reynolds number, okay, so since C and M is depending on the Reynolds number, so you can determine Reynolds number for the cylinder using this formula, okay, where Reynolds number is equal to DO, outside tube diameter, multiply with the velocity of the fluid, multiply with the density of the fluid, okay, this is all the heating fluid, and divide by the mu of the fluid, okay, either heating or cooling, it depends on the application. Now let's consider example 3. Okay, so you have a metallic cylinder 12.7 mm in diameter and 94 mm long, is heated internally by an electrical heater, resulting in an average surface temperature of 128 degrees Celsius. The cylinder is subject to a cross flow of air at, this is the velocity of the fluid, equals to 10 meter per second and average temperature of 58.6 degrees Celsius. Determine the convection heat transfer coefficient H. Okay, first what you have to do is you have to determine the TF. Okay, so TF is equal to TW plus TB divide by 2. So TW is this one, average surface temperature 128 plus TB, our TB is this one, average temperature of 58.6. So divide by 2 and then you will get an answer for TF is 93.3 degrees Celsius. Next, we will be using, okay, after dah dapat TF, next steps is to determine its properties, okay, props, okay, from table A3.3, okay, appendix table A33. So this one, so you check for the temperature 93.3 here, and then what we want is the rho density, and then mu here, since dekat atas ni kan dia mu kali 10 kuasa 3, sorry, 10 kuasa 5, so your exact value of mu would be 2.15 kali 10 kuasa negatif 5. Okay, and then we will want this K value and Prandtl value. Okay, so we know that the diameter here you have to convert to meter, and then the velocity. Okay, this is the velocity of the fluid. Okay, so you calculate Reynolds number. So Reynolds number is equal to outside diameter multiply with the fluid velocity multiply with rho divide by mu, and then you will get the answer as 5694. Next we will find C and M. Okay, so the first step, second step, okay, third step is for you to find C and M constant from table 461 here. Okay, so look at this table. So our Reynolds number is 5694. So the M and C value would be, okay, dari sinilah, dari 4000 sehingga 40000 sini. So the M and C, M is 0.618 and C is 0.193. Okay, so we know C dan M kita adalah 0.618 ni M. Meanwhile C kita adalah 0.193. Okay, this is our C value. Okay, C value. Okay, sebab apa kita nak cari M dengan C ni? Okay, because next step we want to calculate the Nusselt number. Okay, so Nusselt number C tadi adalah 0.193, M ini adalah 0.618, Reynolds number adalah 5694, Prandtl number adalah 0.694. Okay, so use this Nusselt correlation to find Nusselt number. Okay, so Nusselt correlation is equal to H D naught, this is outside diameter, divide by K. So the Nusselt number will be equal to 35,000, 35.771. Okay, and then you plug in value di tadi kan, di apa, outside diameter kita tadi kan 12.7 mm kan, so convert kepada meter, 0.0127 meter. Okay, K pula adalah 0.0, K ni yang daripada appendix tadi, so 0.03115, 0.03115, and then we can easily find out our H. Okay, so ini slide sebelah lah. H would be this one, 87.7 watt over meter square per Kelvin.